design a single angle strut connected to a gusset plate. What do you mean by gusset plate is, you can see here, there is a plate which connects three members, 1, 2 and 3. So these three members are being connected to this plate. So the major member is the bottom chord. In this bottom chord, this will be welded, or you can make it a bolt. Here what they have given is a single member. Take an example, this is an angle section. You are designing this member only. So from the top to the bottom. So this is called a strut. You have three number of strut which is connected to this truss. When you are connecting to this, assume that force which is transferred here is 180 kilonewton. Now you have to design the member. You can see an angle section. Angle section is termed to be as an L section. You have to design for a capacity of 180 kilonewton factor load. The length of the strut between center to center connection is 3 meter. Imagine that this is the length from the center to the center is 3 meter. So you have to design this member which carries a load of 180 kilonewton. Okay. Now you have to design a connection and it is a compression member. Okay. Let us come to this problem. While designing this compression member, first step is to assume the factor load. What do you mean by FCD is, D stands for design compressive stress, F stands for stress. So what is the design compressive stress? You are assuming is 90 Newton per mm square. 60 to 150, you can assume around this. So here it is assumed as 90 Newton per mm square. The sum starts with this. When you are assuming the design stress carrying capacity as 90 Newton per mm square, how you can find the area? What is the formula for force or stress? Stress equal to load by area. So what is the load which is given here? 180 kilonewton, and you can find the area. The load is 180, so it is in terms of kilonewton. You are multiplying into 10 power 3. This will be in terms of Newton. Divided by area. Area has to be found. And you are having stress. What is the design stress carrying capacity is 90. So you can cross multiply this. Force divided by stress is area. Now what is the area required for your member? 2000 mm square. Okay. Now what you have done is, the area of this member required is 2000. Now you are trying two angle section which is having a size of 90 into 90 into 12 mm. You can try with channel section, I section, you can try it. Here it is tried with ISA 90 into 90 into 12. Now what do you mean by 90, 90, 12 is, this is your section. You have the steel table code book. You can take the steel table, and in that you are having rolled steel equal angles. Why they are saying equal angles? In the height as well as in the width you have same dimension. So this is 90 and 90. What is the thickness? 12. This is the section you are assuming. So you have the member at this row. So 90 into 90 into thickness is 12. Now if you are assuming this, what is the area covered? 20.19, which is in terms of centimeter. Now if you want to make in terms of millimeter, you have to multiply by 10. 10 into 10 will be 100. Total area will be 2019. What is the required area? 2000. So you are assuming 2019. Can you take the section 90 into 90 into 10? No, you cannot take. Why? Because what is the area covered? 17.03, that is 1703. Now your area required is 2000. Take the member much higher than that. So this member you can try it. In the steel table you have radius of gyration. This is moment of inertia, which is Ix and Iy, and radius of gyration. You have Rx and Ry. What is the least? You are having Rx as 2.71 and Ry as 1.74. 1.74 is the least. So you have to take least of the radius of gyration in terms of centimeter. So if you want to convert in terms of millimeter, 17.4. Your radius of gyration is 1.74 in centimeter. In terms of millimeter, it is 17.4. Assuming the strut will be carrying a gusset plate of at least 2 bolts. See that here you are assuming that in this gusset plate, assuming 2 number of minimum bolts are there, and assuming a bolt connection. That strength of 20 mm bolt in shear will be 45 kilonewton. Check for plate, check for bearing strength, check for shear strength. So three things you have to do. When you are doing that, if you are using 20 mm bolt, you will be getting value of 45 as the least. You can take it now. In the next problem, we will be checking this. Now, how to design? Design for a compression member, you need radius of gyration. What do you mean by radius of gyration? KL by R. This is the ratio which you have to take it. What is K? K is a constant, KL. Where you will get this? You are having this condition. In compression member chapter, you have this in code book. In 45, you can see that if you are having bolt, one end hinged and another end is fixed. When both the ends are hinged, you are having value as 1. Now your condition is, you are assuming 2 bolt. It is neither fully pinned or fully fixed. So you can assume around 1 to 0.8. Here it is assumed as 0.85. So what is your length? Length of the member is 3 meter. So if you multiply 3 into 0.8 will be 2550 mm. Now what is the radius of gyration? R is 17.4. What is the slenderness ratio? If you divide this two value, you will be getting 146.55. Design compressive strength PD of a member is given by external force which is acting. Your design strength, what is PD is? Design compressive strength. D stands for design, P stands for force. So design compressive force should be always greater than the load. This member has to carry 180 kilonewton. Your design should be more than 180 kilonewton. Okay. Now, how to find PD? They have given a formula of AC. What is AC? Effective cross sectional area. 20.01. That is 2001 is your area. Now you know this. How to find FCD? Design compressive stress. Buckling class of your cross section. Since you are taking L section, your buckling class is C. Now take down buckling class C. Table 9C. For 140 you have 66.2. For 150 you have 59.2. For 140 the value is 66.2. For 150 it is 59.2. What is the value of X for 146.5? So you will be getting 61.6. Let us take this and you can apply for this value. You got 2022. See, your area, cross sectional area is 2019. 124 kilonewton. But what is your force which is acting? 180 kilonewton. The load coming here is 180. What is the load carried by this member? 124. It should be greater than the load carrying capacity. If 180 kilonewton of load is coming, this member is going to get collapsed. So this is what in this formula always PD should be greater than the P. Yes or no? The class 7.1.2 they say that PD should be always greater than P. Now you try higher section. Higher section is, now you have tried 90 into 12. Now around 1/3 of the force which has to be taken additionally. Now let us try 130 into 8 mm. 130 into 130 into 8 is 2022. This is your area, and what is the minimum radius of gyration? 4.03 and 2.55, which is least. 2.55 is least. Now your area is 2022. R minimum is 25.5. 0.85 into L, which is 2550, divided by what is R now? 25.5. Your value is 100. For 100, 107. Directly you have the value of 107. Now you can multiply FCD into A. FCD is 107, 216 kilonewton. Now what is the design capacity is 216 kilonewton. What is the force coming? 180. Either this member will carry? Yes, definitely it will carry. So it is much higher. When you are practically designing, you can try the lesser section. What is that? Instead of trying 130 by 130, you can try lesser section. Now this value will get matched. So providing IS 130 into 130 into 8. This is your design. Let us go into design of laced column. Have you seen this kind of column in the railway structure, railway bridges? You will be having the column like this, and you will be finding this kind of lacing. So this is cross plates. This is similar to your shoelace. That is why it is called design of laced column. Why? Because it is carrying the load in compression, and when carrying this kind of load, when your load is much higher, if load is 180, 100 kilonewton, 200 kilonewton, which is very less, only one member can carry. If your load is more high, 2000 kilonewton, 3000 kilonewton, if like those forces are coming, it is better to go for a composite section. What do you mean by composite section? Carrying two members. Can you see a channel section here? Both the channel sections are here and connected by lacings. So this is known as lacings. Okay, now you will be studying how to design this lacings. As per IS 800 specifies the following rules. First one, as far as possible, the lacing system should be uniform throughout. You can see here that the lacings are similar. If you look into one cross section, there will be same thing which will be coming at all the points. It will be uniform. In a single laced system, the direction of lattice. What do you mean by lattice is this plate. One single plate is called lattice. The lattice on opposite face should be shadow of each other. If you are providing lattice in this direction, in the opposite side there should be same manner of lattice. In bolted or rivet construction, the minimum width of lacing bar shall be 3 times the diameter of the bolt. In this lacing, you will be having a bolt. Now for connecting this, they use bolt. If you are providing 20 mm dia bolt, what does this third point says? The width of the lacing, this is the width. Width of the lacing should be 3 times the dia of bolt. Now if you are assuming 20 mm dia bolt, 20 into 3, which will be 60. So your width of the lacing should be 60 mm minimum. You can provide more than that, but not less than 60 mm. This is a single lace, that is lattice. This thickness should be not less than 1/40th of effective length. Double lacing, this is one portion and this is another portion. So if you are using double lacing, your effective length should be 1/16th of effective length. Lacing bars shall be inclined at 40 to 70%. So your angle of lacing should be between 40 degree to 70 degree. The distance between two main members should be kept as to get Ry is greater than Rz, where Ry is the radius of variation of weaker axis, Rz is the radius of variation of the stronger axis of the individual. When you are using any member, you will be having two radius of variation. Check that in the previous problem, you will be having Rx and Ry. If the distance between the two lattice is much wider, then your strength radius of variation will increase. If you reduce the distance between these two elements, your radius of variation comes down. If you have any member, you will be having a slenderness ratio. Here they have given the maximum slenderness ratio for the connection is 50 or 0.7 times the most unfavorable slenderness ratio of the hole. Lacing force is 2.5 times the axial force in column. For the previous case, for the previous column you had 180 kilonewton of load. How to find the lacing force? 180 kilonewton into 2.5%. That is the force, and this will be the force which has to be resisted by the lacing, that is Vt, transverse shear. So this is one stretch of lacing and this is another stretch of lacing. If you provide two lacings, you can divide for each. If the column is subject to bending, Vt will be bending shear plus 2.5 times column force. You have to find bending shear plus 2.5 times the column force, which is already dealt in 0.8. V is known as shear. If it is purely axial, you can take 2.5 times of column force. If additional force is there, you have to consider that. So this is the length between inner fastener, L, which is known as the effective length of a single laced system, is equal to length between the inner fasteners for weld joint and double laced. The effective connection At intersection, effective length may be taken as 0.7 times actual length. And the slenderness ratio should not exceed 145. You can see this is a single lacing. You can provide lacing by different types. You can see a horizontal member at equal intervals and only one lace at all the boxes. So this is one type of lacing. And you can provide this zigzag lacing. You can use double lacing. If you are using double lacing, you can reduce your force divided by 2. This is a real structure. Can you see what kind of lacing they have used? Single lacing. They have not used double lacing. If you are using double lacing, it will be like this. Okay. Laced compression members shall provide with end tie plates. At the end, you will be having a tie plate. So can you see a plate here at the top? At each and every junction you will be having a end tie plate. So at the end you will be having a tie plate. The effective slenderness ratio of the laced column shall be taken as 1.05 times actual maximum slenderness ratio in order to account for shear deformation effect. Slenderness ratio, whatever you are getting, KL by R, when you are using lacing system you have to multiply that value by 1.05. If you are not using lacing, you don't need to multiply 1.05. This is due to shear deformation effect.